Okay. Last week we discussed about the cache memory. Today we are moving to the random access memory. So random access memory means uh, we call it as volatile memory. So RAM is the main memory of the computer, and it hold the data for running application required for the computer. So while processing, we have to store the data uh, in temporary memory. So there are two types of RAMs: SRAM, static random access memory. So we call it as a flip-flop logic case. So flip-flops mean the SRAM, which provide us that's a random access memory that retain data bits in its memory as long as the power is being supplied. So when the power is supplied, it hold the data, but when you switch off the machine, the data will vanish. So therefore, we call it as uh, volatile memory. So random access memory used for the cache memory and register memory. So it is faster than the DRAM. SRAM is made out of transistors, registers. So since the transistors are uh, only the transistors and registers available, it doesn't contain the capacitors. Therefore, it does not refresh. So while the capacitors are there, it normally charge and discharge. So since it is not refreshing like dynamic random access memory, it is faster than the DRAM. So SRAM is faster than the DRAM because DRAM contain the capacitors, but SRAM doesn't contain the capacitor. So therefore SRAMs we call it's faster. And cache memory L1, L2, L3 is made out of the SRAM. So when we discuss about the dynamic random access memory, there is a second type what we are going to discuss under the random access memory. So dynamic random access memory is a normal RAM card which we use in the main memory. This type of RAM is continuously refresh or it will lost its content. So normally it is keep on refreshing. So it made out of transistors, capacitors, and registers. Since it made out of the capacitor, it will charge and discharge refreshing. Therefore, it is slower than the SRAM. So normally we can purchase 8 GB, 64 GB random access memory, RAM cards. So D random access memory mean SDRAM. So SDRAM mean synchronous dynamic random access memory. Synchronous dynamic random access memory used for to keep the the time clock in the machine. So it's a type of memory that synchronizes itself with the computer's system clock. So when you switch off the machine and next day when you switch on it, you will get the same time. So like this random access SRAM, that means SDRAM, synchronous dynamic random access memory, help for the computer to keep the system clock. So it's a type of memory of which that synchronizes itself with the computer system clock. So to keep the system clock, this synchronized dynamic random access memory is necessary. When we check the RAM, so this one is the DRAM, dynamic random access memory, and it can the I told you L1 cache and L2 cache reside with the processor CPU, and L2 that means some or not all the L2, some L2 caches are reside in motherboard and L3 is reside in the motherboard. So that's all under the random access memory. So we'll copy down these two slides. What is non-volatile memory? So we are going to discuss about the non-volatile, that means permanent memory. So this is a type of computer memory that has capability to hold save data even if the power is turned off. So when the computer switch off, even data will save there in the memory. So we call it as the non-volatile memory or as the permanent memory. magnetic memory, optical memory, static memory, flash memory, static or flash memory. Then ROM contains the CMOS setup, so that means switch on-off self-test and manufacturing information about the machine boot up setup is reside inside the ROM chip. Then first we are going to discuss about what is ROM. So ROM means read-only memory. So retain its content when the computer is turned off. So when computer switch off even, and next day when you switch on it, the data will keep remain. The normally manufactured information and the boot up program is available there in the ROM chips. So ROM stores essential programs such as program that boots the computer. Types of ROM: PROM, programmable read-only memory. It is a memory chip on which data can be written only once. So once a program has been written into a PROM, it remains forever. So we can take it another day, even the information which are stored in the PROM. So EPROM, erasable programmable read-only memory, is a special type of memory that retains its content until it is exposed to the ultraviolet light. So erasable programmable read-only memory data will remain until we expose it to the ultraviolet light. So ultraviolet means UV. Ultraviolet light can erase the data which is stored in the EPROMs. So ultraviolet, I think you may know that ultraviolet means that we take the UV. ඒ වගේම තව වර්ණාලෝක කරනවානේ ඔයගොල්ලෝ වල ඒකේ ලයිට් ස්පෙක්ට්‍රම් කියලා කියන්නේ සිංහලෙන් නම් ආලෝක වර්ණාවලිය. හරි සිංහල ඉංග්‍රීසි වලින් කිව්වොත් ලයිට් ස්පෙක්ට්‍රම්. සෝ ඒකේ අපේ ඇහැට පේන එකට එහා අල්ට්‍රාවයලට් තියෙනවා. ඒතකොට ඒ අල්ට්‍රාවයලට් ලයිට්ස් වලින් පුළුවන් එක පැත්තක ඉන්ෆ්‍රාරෙඩ් අනිත් පැත්තේ අල්ට්‍රාවයලට් ලයිට් වලට පුළුවන් මේක ඉරේස් කරන්න. So electrically erasable programmable read-only memory electrically erase කරනවා. හැබැයි මේක අපි expose කරොත් එහෙම මේ ultraviolet light එක erase වෙන්න පුළුවන්. The ultraviolet light clears the content, making it possible to reprogram the memory. So using the ultraviolet light can reprogram the memory. EEPROM, electrically erasable programmable read-only memory, can be erased by exposing to the electrical charge. So EEPROM can electrically erase with the help of the electrical charge. So first we'll copy down these two slides. Then after that we'll move to the next one. Secondary storage devices. So secondary storage devices we can move into mainly three: magnetic storage device, optical storage device, and solid state storages. Magnetic storage devices are used for the magnetic field to read and write the data. Magnetic storage uses the different patterns of magnetization in magnetizable disk surface. So there is a magnetizable disk surface. Then it arranged according to the given magnetic field. So magnetic storages are different, use different patterns of magnetization in a magnetic disk surface. Magnetic in storages use spinning disks or platters and read and write headers on an armature. So spinning disk is there and platters are there. Read and write headers are there with the armature. So hard disk, internal hard disk, external hard disk can take as examples, as well as floppy disk, magnetic tapes, zip disks. But floppy disk magnetic tapes are very rarely used now. Those are outdated. So magnetic tape medium is similar to cassette tape that move by read and write headers, but we are not using the magnetic tape nowadays. We'll discuss after this one how magnetic storages are work. First, we'll copy down these two.